Good morning and good evening, friends. Welcome to goonlinetrainings.com. So, today let us understand the architecture of Hadoop cluster, right? Because the big data platform started with Hadoop. So, Hadoop is going to be storing your data in a decentralized manner. That is, it's going to be creating a cluster. Cluster means multiple machines are going to work together. So, vertically, we will not be able to increase the RAM and the CPU capabilities in a given computer. Instead of that, you will be able to have a cluster, multiple computers or nodes you can increase so that unlimited data can be stored. Right? That is what we have discussed. And today we're going to be talking about Hadoop daemons. So nothing but your Hadoop services and Hadoop replication factor in the Hadoop, and what is a name node and what is secondary name node, and what is a job tracker and what is a task tracker. All these things we're going to discuss today. So yesterday I was talking about a couple of points. So what was yesterday's topic? So yesterday I was talking about what is OLTP versus OLAP, and what is data warehousing, and what is data lake, and data warehousing plus we were talking about data lake. You got a new concept, that is delta lake or lake house, right? So this is the new concept got realized. This is what we have discussed, right? So data warehousing is nothing but your SQL will have a concept called acid properties. Because of that, it is going to be maintaining perfect data or correct data. Data lake is similar to your folders, okay? Folder. But in your folder, it is not guaranteed that you will be able to have the acid properties here. That is the reason data lake can store unlimited data, but the problem is that you need to compromise the quality. That is the biggest issue with the data lake. Data lake is means a folder. Instead of creating your folder in Windows local operating system, you are going to be maintaining the folder in the cloud. So it is a rental platform. Somebody is going to be giving you a Google Drive. It is a data lake only, or OneDrive is a data lake only. It is a folder. So folder cannot have acid properties. What is acid properties? Atomicity. Right? It is SQL concept actually. So SQL, when you know clearly, people are going to be talking about this one, atomicity, right? Acid properties, atomicity, durability, isolation, atomicity, and what is the spelling? So consistency, right? And isolation and durability. So these are the concept. Atomicity, is it right or wrong spelling? It is not telling me anything. Spelling. Yeah, atomicity. Atomicity, consistency, isolation, durability. Because of this four concept, either data warehousing or your any SQL, RDBMS, Oracle, SQL Server, MySQL. Because of this, you are going to be maintaining high quality of data, right? High quality of data we are going to be maintaining. But this is impossible in your data lake, because data lake is going to be bigger than your data warehousing. So as we discussed already, this is your entire global data. So when you take entire globe, so only SQL data will be 20%, right? Remaining 80% of the data will be non-SQL data. So non-SQL data means it is going to be your big data we're talking about, or it is going to be data coming in the files. So this data, where is the today? It is going to be there in data lake, right? Data lake. So data lake data is going to be used. That is 80% of the data today. Is 80% of the data today going to be used for AI, right? AI can take only this data, but 20% of the data today where only BI is going to be working. Business intelligence only on the structured data, and non-structured data, files data, data lake data will be where AI is working. So the big data more probably is going to be working on this. But for this, we have already SQL. We need not worry about it. So this is what is your Databricks or any big data tools are going to be focusing on. The biggest problem with 80% of the data is the quality, right? Quality is not guaranteed because here no asset properties, atomicity, isolation, this one. So we'll create one proper session on this one, so that you can watch. And the SQL, anyhow, you have asset properties, okay? Because of that, the quality can increase, the quality can be decreased. It can increase here, this can be decreased here. But so whatever be the atomicity that is there in the delta lake, it is going to be your data warehousing plus your lake, right? Your lake concept is going to be implemented together. It is a delta lake house given by Databricks. Because of that, why, what is the purpose of this? Only simply I wanted to increase the quality of the data, quality of the data. Because if you don't have the quality of the data, AI will give you wrong predictions, right? If the data is not so correct, what will happen? Either here or here. If you don't have high quality data, you need to compromise the output from here, right? If you don't give proper chicken for the biryani maker, so you cannot expect good biryani, right? So the raw material for AI or a BI is high quality of the data. If you don't maintain high quality here, then definitely you need to compromise the results, because it is output that we are going to be using it. The predictions may go wrong, or your data and business intelligence where your the past data also will not be very good. So quality is the biggest problem in the big data environment. Remember this. People will ask you this question, many times. Why delta lake is, more important? What is the problem of a data lake? What is a data lake, right? Why people have to think about this? Because quality, because asset property is not there. But today, when you store any data here, you're going to be creating what is called as a delta table. You're going to be creating delta tables. In the delta table, everything you can implement. You can implement insert, update, delete, and you can have asset properties. Everything you will be able to implement, so that it is similar to your data warehousing or SQL concept only, but it is not a pure database. It is a delta lake concept. We'll talk about at least 3 to 4 hours of delta lake later. So that is very very important, guys, right? The purpose of delta lake, to have the high quality of the data. If you have the data in the data lake, you're compromising the quality. If you keep the data into the data warehousing, high quality, but data warehousing will store only structured data. So but if you have unstructured data, semi structured data here, you're going to be compromising the quality of the data. Maybe duplicate data, unfinished data, blank columns data, misspelled data, lot of things may have. So biggest problem with the data lake is what? Today, quality. Big data, biggest problem is quality. Remember this point forever, right? Now, what is OLTP? What is OLAP? That is also I have given you the brief description yesterday. These are important interview questions. You need to know clearly what is OLTP and what is OLAP according to Dr. Dr. Cod, uh, Dr. EF Cod, right? So this guy has given the RDBMS concept. According to him, these are the two types of databases only, right? Two types of databases only. So that is what you need to understand. DBs, right? So OLTP and OLAP, and what is the difference between OLTP, OLAP, that you need to know. OLTP is going to be storing what? It is going to be storing the small data, right? Or it is going to be storing your transactional data, daily transactional data. So whatever you do, it is going to be storing your transactional data, daily data. It is going to be storing your historical data, right? So it is going to be having small size data. The data may be in GBs, right? It is going to be having large size data. So large size, maybe the data will be in terabytes of data. So here we are going to be having more read and write data. So 80% of the time you are going to be busy with writing of the data. So OLTP applications are designed to increase writing capability. Right? OLAP applications will have read only data. It is going to be designed to read the data. Right? Here, normalization is used here. In this, denormalization is used, right? Normalization means, so what we are going to be thinking, normalization means removing the redundancy theoretically, but normalization will create smaller tables, and lot of smaller tables it's going to be creating. So it is, when you create a smaller tables, writing capability will be very, very faster. Now I'll be talking about in the data warehousing 10 hours of videos you must watch. In that, I will be talking about what is a normalization, what is a denormalization, why normalization writing capability is very speed. In denormalization, why reading capability is more. I have clearly spoken in my data warehousing videos. You must watch those 10 hours of videos without fail. Clear? So normalization will give you lot of small tables. So you'll have a lot of small tables. Hundreds of tables are going to be created. Normalization is going to be splitting data into small multiple tables, right? You may have 100 tables here, but in the denormalization, you're going to be having a bigger tables, only a few tables like that. So you may have some 25 to 30 tables here, right? So remember, normalization will split a bigger table into smaller tables by removing the redundancy. Denormalization is going to be doing it to, reverse. It is going to be taking four tables and creating one table. It is going to be taking another tables, creating one table, like that. OLAP or data warehouse here, you're going to be having so small, right? Data warehousing means OLAP. So you have small tables here. To implement this ERD designing technique is used. So to design a data warehouse here, dimension modeling. Okay, dimension modeling technique is used to design your data warehousing. So this technique also I have discussed in my data warehousing videos. You must watch. Clear? So it is where you are going to be most of the time end users are connecting to this, whatever be the application that you're going to be using today. Banking application, maybe irctc.co.in, or maybe any application, pay, Google Pay, your banking application, loan applications, you're buying a movie tickets, everything that you're going to be using, all of them are called OLTP applications. OLTP will have a fresh data, right? Transactional data, the better you can say, it is going to be having a fresh data, right? Whenever, whichever be the application is going to store the fresh data or a transactional data, that's OLTP, online transaction processing. Whichever application is storing historical data, that is OLAP. End users are going to be connected to this. So business users are going to be connected. That means the people from the business, maybe CEO, CTO, sales managers, regional level managers, are going to be taking the OLAP data and try to connect with this. This is going to be for the to run the business. To run the business, we're going to be using this is going to be to improve your business. So what is the purpose of this? To improve uh, the business. So all of them are very, very important to improve the business. We're going to be using these applications, right? So end users are connected. Now less indexes you're going to be connecting, because indexes are helping reading, but normally we're going to be writing here, right? Indexes are used to increase your reading capability. OLTP database is going to be designed to take more data into writing. So less indexes we need to create, and more indexes we're going to be creating. Am I clear? So normalization will be increasing the writing capability. Denormalization is going to be increasing the reading capability. Denormalization is going to be creating lesser number of tables. When you have a lesser number of tables, what will happen? You will have a less joins. When you have a less joins, you can get more readability. Clear? Denormalization will create lesser number of tables. Lesser number of tables means a lesser number of joins. Lesser number of joins means maximum readability. Normalization creates many number of tables, right? So you have 100 tables here. More tables means if you wanted to retrieve the data, more joins, right? When you have more joins, it is slow in reading. Clear? Remember, this is also one more point. I will be able to talk all these points in my data warehousing videos. OLTP, you have much more tables, and more tables means more joins. Joins are complex operations, not very simple operation, not very speedy operations, right? Joining 100 tables will give you a lot of performance degradation. Joining 20, 30 tables will give you higher performance. That is the reason OLAP applications are designed such a way that reading capability has to be more in the data warehousing. So people will ask you how to design your data warehousing. Can you tell me from starting to end? If I give you an OLTP database, can you design one OLAP database or data warehousing database from starting to end? Yes. So watch my 10 hours of data warehousing videos. Beautiful content I have given. You will be able to know how to design your data warehousing from scratch. Clear? I strongly recommend either now or after some time you must watch data warehousing step by step. From starting to ending. How do you build? So this is very very important. So what is ERD modeling? Entity relationship diagram, dimension modeling, designing techniques. We're going to be using it here. So ERD modeling, I will be able to talk about in SQL videos, but this one data warehousing videos I have. So these videos also available in my YouTube channel freely. You can also go to my Go Online Trainings YouTube channel. Some 7 to 10 hours of videos are available. You can just watch them there as well. Clear? Chalo guys. These are couple of points that you need to say. OLTP refers to a database only. Even OLAP data warehousing refers to a database only. People may ask you, what is a database and what is a data warehouse? What do you say? People may ask you this kind of interesting questions. So, database versus data warehouse. So, what is the difference between these two? You have to say data warehouse is a large database only. It will have historical data, read-only data, and denormalized data. It is going to be used to create your, reports and everything. So that's what you need to say. It is a decision-making system, blah blah blah. Because OLTP, where we are not going to be having so much of a data here, so reports we never create on the OLTP systems because you have last 3 months data, 6 months data. But if you wanted to create a decisions or if you wanted to take a decision, you need to have a large data. So this is a decision making a tool. OLAP means online analytical. You can analyze the data. When can you analyze? When you have a large amount of data. Otherwise, analysis will be wrong, right? So that is what you need to have complete history about the company. OLTP, even though you create a report, you may create a Power BI reports or any reports here, but these reports cannot be OLAP reports. You cannot analyze anything. Even though you create what is the yesterday's sales, what is the last 3 months sales, what is the last 1 year sales. With this data, you will not be able to analyze the complete the company's the issues and problems. So we never create. We create a reports here, but these reports are not OLAP reports. OLAP reports means you need to have a large amount of data. Any decision you will be able to take it. So more reporting is going to be done on your data warehousing only. Remember that data warehousing is a large database. It may be Oracle database, SQL Server, Teradata database, or DB2 Net is anything that you can choose it. Yeah, am I clear? So these are very very important points that you need to know clearly. Guys, are you clear? So what is OLTP? What is data warehouse? I have clearly explained. Now today I want to go tell you what is Hadoop daemons. Daemons means services. When you go to uh, start and run, lot of services in Windows operating system you're going to be having it. So what are they? How do you check the services? You need to go to start and you say run, then you say services.msc, right? When you give this command, you will be able to see services means applications are that you have installed. So each application is going to be giving you one service, right? If you have a kidney is a device, hardware, it is going to be giving you a service. If kidney doesn't work, even the application is there, sometimes it is not working. Your heart is there, it is not working. So if something is working means it is giving you one service, right? Applications in action is called as a service. If kidney is working, it is giving you one service. Your brain is working, it is giving you one service. But the brain is there, but it is not working means it does not give you any services. Services means the application that you have installed, which are working and give you some services for you. So how do you check what are the services you have? So any application, whatever be the application that you're going to be using, that will create lot of services. Go to start and you in the run, this is the run, you can say services.msc. Let me simply go and try to say services.msc or simply services. You will be able to get this window. Click on this window. So these many services are running. Whenever you install any application, for example, I'm using a lot of services here. So all these things are working. SQL Server working, whether it is running or not. Sometimes, if it is not working, perfectly fine. If it is not working, for example, when you open SQL Server, it is now started. It is running, right? You can also switch off this so that it will get stopped immediately, right? So whether the server is running or not, you will be able to know. So however, you have SQL Server services, Windows services, or you may have a lot of things, right? Windows wide auto configure, Windows search service, lot many applications are running in my operating system. Have you seen this? Now whenever you install a Hadoop, how can you install Hadoop? I told you, to install a Hadoop, you need to have to buy, you need to get a machine. Maybe smaller laptop, bigger laptop, doesn't matter. First of all, we are going to be installing Linux operating system. That is what is recommended for the Hadoop or Spark. Windows is also fine, but in Linux, a lot of flavors. What is the flavor? We're going to be using Ubuntu. Ubuntu is one flavor. In Windows, we have Windows XP, Windows 7, Windows 10, Windows 11. So you have different versions in Windows. In Linux, we have Ubuntu, Red Hat, like that. Many flavors we have, right? So you can use any one of the flavor, either this or this. The next one, Hadoop is created. Hadoop and Spark is created using a Java software latest version you have to install, maybe 11, 12, whatever be the latest version. So Java. Then you have to take and install Hadoop. Apache company is going to be giving you free Hadoop software that you need to install. Clear? So these many things that you need to install if you wanted to run your Hadoop cluster. All the machines, if you have a three machine, this is one machine. If you take one more machine, and this is a one machine, this is one more machine. So all the machines completely you have to run all the softwares. So in this machine, in this machine, in this machine, in this machine, everything you need to install. Linux, Java, then Hadoop. Linux, Java, Hadoop has to be installed here, installed here, installed here, installed here. Everywhere you need to install. So whenever you install, you will get lot of daemons that are going to be created. Services. Daemons meant what? Services. So however, I have shown you the services. Those are called daemons, right? So Hadoop cluster daemons. So you have name node. It is also called as a master node, and there is a data node, and there is a secondary name node. We'll talk about this one also today. We are going to be having different services in Hadoop 1.0 version. We have daemons like job tracker, task tracker, and all these are different applications, or you can say daemons means services, right? Hadoop 2.0, 2.x, we have a resource manager, node manager. All these are small applications. Means small code, piece of code is going to be running, piece of code will be running. So these are different applications we're talking about. So yeah, make clear. So secondary name node also will have some applications. Name node also will have some applications. Data node also will be having some daemon services which are going to be running. Right. So what is a job tracker? What is a task tracker? Everything we're going to discuss one by one now. Now, if you install any Hadoop cluster, why are we talking about Hadoop cluster? Because a Spark cluster is going to be having the same thing here, same thing also. We need to understand Hadoop cluster. Hadoop is not there today, but many companies are running to store your data in Hadoop. For the processing purpose, Spark cluster can be used, right? So we cannot say I don't know anything about Hadoop. You need to know this. So you'll have one master node, and you will have a driver node or a slave node or a data node or worker node. So these are different words. So people will say this is a master node, this is also called as a driver node, or this is called as a worker node, slave node, data node. Whatever you wanted to have it, you will be able to have it. So whenever you install, I told you Linux, Java, Hadoop, Linux, Java, Hadoop, Linux, Java, Hadoop. All these are machines. All these are computers, right? Each node is a physical computer. Maybe your laptop, my laptop, installed with those things. And whenever you install, these many files are going to be installed in every machine. So you go in core.site XML. If you mention IP address of a master computer, what will be the master computer, or what will be the driver computer? If you go to any machine and open core.site XML, you have to provide the IP address of that machine. That machine will be acting as a master node. Clear? And in the slaves.txt, in that you're going to be mentioning IP address of slaves. Slaves means data nodes. All the things you're going to be having it. So you will be having few XML files, few this one, TXT or CSV files. You need to mention IP address dot master. So wherever you mention, for example, you take one computer. In this computer, open this file. You mention the one IP address there. So whichever be the IP address that you're mentioning, that computer will be called as a master machine. Clear? So that is what you need to understand. Now, second thing I have told you, it is going to be taking your data. Hadoop is going to be taking the data and creating a blocks. So what is the blocks? By default, the block says in 128, that in Hadoop, this can be modified. You can make it to 64 MB, you can decrease, or you can increase to 256 MB. This size also you will be able to modify. So depends upon the data. So total number of blocks, it is going to be created number of what is the file size. For example, your file size is 1 GB, right? So 1 GB means it is 1024 MB. This is what I'm talking about. So divided by 128 MB, you will be able to have 8 blocks. Clear? So how are you deriving number of blocks here? It is going to be 1024. You need to convert into MBs. And what is the block size in Hadoop? It is 128. Can we modify this? Yes, you can decrease or increase here. It is a configurable option. Means you can change the size. It depends upon the data that you're acquiring, and depends upon the data that you have it. Clear? So this is what you need to understand. So one, two, three, four blocks are going to be going, and master node is going to be maintaining metadata. So whenever you supply the data to the cluster, so cluster is going to be putting the data into the data node or slave nodes. No data will go to the master node. Master node is going to be maintaining where is the slave number one or data node number one is going to be having block number one, block number two, block number three. Master node does not have the data. The slaves or data nodes, worker nodes are going to be storing your data. And if you wanted to work with the data, you need to give the data and you need to supply the code also, right? So data you have supplied, code also you need to supply. For example, I wanted to know number of rows in the sales data. You need to know number of rows in my sales file. If you wanted to find out number of rows, the code also should go here. 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 Right? So this is your data. In this data, this code is going to be executing, giving you some output. This code is going to be executing on this data. This code is going to be executing on this data. Everybody is going to be giving you some outputs. This output, maybe it will be telling 10 rows, 20 rows, 5 rows, and 10 rows. So this will be block 1 number of rows, block 2 number of rows, block 3 number of rows, block 4. But all these blocks are nothing but your sales data. So this will be taken finally, and you're going to be getting final output 10 plus 20, 30, 35, and 10, 45 rows. So end of the day, these will give you intermediate results. This is not the final result. Clear? It is going to be giving you intermediate result. So by using a processing technique called map reduce. Okay. So if you wanted to process, so number of code, number of rows I wanted to write. So you need to write the code. So for the storing data, we were using HDFS, right? So in Hadoop, we're going to be having distributed file system. So here it is going to be storing. So after that, we're going to be having map reduce Java code you need to write. With the help of a Java code, it is going to be, it is going to be, getting the data. Then afterwards it's going to be taking and reducing means combining all the intermediate data. It is going to be taking some data and work with the block 1, block 2, block 3, block 4 data. Then finally reducer is going to be there to combine the data. So map reduce, we need not understand, it is a mapper plus the reducer functions are going to be there. So mapper is going to be dividing, and it's going to be creating key value pairs and try to do the executing the logic. Then reducer is going to be taking all the intermediate data and try to give the final data. So map reducer is completely gone today. We are not going to be using, but you should know mapper and reducer is a Java concept that is implemented to find out number of rows in this table. So here only difference is we can get number of rows in the a single table or a single file. That is very simple concept. But why the complexity is going to increase? Now your task is going to be distributed in 10 or 20 or 30 machines or hundreds of machines. Now the difficulty here, same Python code has to work in thousands of machines putting together. So that is a difficulty. Python code in single machine something different. PySpark code means the same Python code is going to be distributed in across machines, and it has to work to work together. In between, if something goes wrong, so that is where the problem starts, right? For example, suddenly this machine started stopping, right? So as I told you, every 1 minute or 10 minutes this machine is going to be giving a heartbeat to this very very important. Every 5 minutes or 10 minutes, what will happen, this machine is going to be giving a heartbeat to the main computer. So main computer knows that this guy is working, this guy is there. So if anything is not sending any signal every 10 minutes, master node knows that this machine is gone dead. Clear? So how master node knows that these machines are working, right? Live and working, because there is a heartbeat that is what automatically implemented in your cluster. People will ask you this question in the interview. It may be 1 minute, 2 minutes, but normally every 10 minutes it's going to be sending the, what do you say, uh, the signals saying that I am live. So then master nodes know that okay, this data already I have given it to this fellow, it can work. But what if any compute, all of them are computers only, right? All of them are computers. Your laptop will be one node, my laptop will be one more one more node. We can install the software and configure it, and all of them are working together. And if one laptop is not sending any heartbeat for more than 10 minutes, this computer will decide this is not working perfectly. If it is not working, what is that we should do? The second case I'm going to be explaining now. So heartbeat, you need to know, master node will not store any data. Only worker node or slave node, data node will have a data. But now question, if something goes wrong, what will happen? Let us understand. I have taken sales.txt file. So I have block 1 and block 2. And in the previous example, what I was talking about, if something goes wrong, what will happen? So here we need to understand in HDFS site.xml, there is one more parameter that we're going to be configuring, replication factor. So it is a configurable option. Replication, make it to 3, make it to 2, make it to 4. So how many copies of the data I wanted to maintain? For example, this node fails. If this node fails, B3 data, I do not have it here. I do not have it here. I have only here. So this machine is not working. Then how do I complete my job? Because my job is count number of rows in this table, right? So unfortunately, this machine is not working. The block B3 data is not available here, is not available here. Then how master node will say, hey, you take the data and try to you try to configure, because the data is already gone. This machine is not responding. If you maintain one copy of the data, if the machine is not working fine, you lose the data, then the complete work will not will get completed. So to avoid this, the Hadoop has one more important concept, replication. Replication means a backup copy of the data. So how many times I want to make the copies? I will say 2 copies of the data. So B1 will be 1 copy here. So I can also make one more B1 copy here. So 2 copies I'm maintaining, 1 copy here. So slave node will have B1, right? Like that. So S4, this is slave number 1, slave number 2, slave number 3, slave number 4. Slave number 4, you have a B4 and a B1 data also. Clear? And 2 copies of data we need to maintain. B1 is available, so B2 data may be available here. So 1 copy is available here. B2 second copy is available. In the S1, you have a B1 and a B2 also available. Right, B2. And B3, where it is available? B3, 1 copy is available here. B3, you can also keep it here. Like that, you are going to be having two copies of the data everywhere. Right? So B3, you have it. B4, so in your S2 machine, you have a B2 and a B3 is available. Like that, you're going to be having. So B4 is there. B4, maybe you're going to be keeping it here, or B4 also, if you have a space, you will be able to copy the data elsewhere. Like that. So one machine can have the duplicate copies of the data. Remember, it is very, very important. For example, I have taken B1 and B2. So I'm writing here. So in that machine, I'm going to be saying, so data node 1 is going to be having a block 1. Data node number 2 is going to be having a block 2 as of now. Because of replication factor, I have to maintain how much. What is the cluster I have? 5 node cluster. This is machine number 1, machine number 2, 3, 4, 5. This is a data node 1, data node 2, worker node, data node, slave. All of them are synonyms. So 1 copy is here, second copy is here, third copy I wanted to keep it here. The second copy for B1, one more copy is here, and B2, one more copy is here. So you can say data node 1, you have this data node 1, this is data node 3. If you have a machines, you have again B1, and data node 4, you have B2. So what will happen? Always you are going to be maintaining 2 copies of that. Suddenly, this machine is not working. Suddenly, this machine is not working. So it is not giving heartbeat to every 10 minutes or every 5 minutes, whatever be the given time. If it is not working, the name node is going to be verifying where is my data. Where is this data? B2 data is available not only here, but also it is available in this one. It is going to be giving the signal to this machine to start the work. Clear? So name node is also maintaining only the which machine is working, which machine is not working, and where is my data properly allocated. Everything you need to understand, and you need to configure properly. So replication will be having here. Because of that, if the sales data file is 100 MB of data, so if you're maintaining 2 copies of the data into two, you will be able to get a 200 MB of data in your cluster. Remember. So actually cluster size you need to calculate like this, because your replication size is a 2. 2 means 100 MB of data will be replicated twice. So 200. If we have 100 terabyte of data, right? If you have replication is a 3, so you need to maintain 300 terabytes of data in your cluster. Remember that. So replication size depends upon that. You cluster number of nodes that you need to increase, right? Because you're not going to be copying 1 copy of the data. By default, Hadoop cluster maintains 3 copies of data. By default, if you don't configure anything, Hadoop is going to be maintaining 3 copies of the data. Means 100 terabyte of data will get a tripled, right? If the second machine also does not work, then you're going to be giving the work to the machine number 3 wherever the data is available. Clear? So there are some rules here. So you can have block 1, block 2 in the same node itself, but the same block cannot be there in the same machine itself. For example, block 1 is there, right? I need to create a block 2. Block 2 you can keep it here, and the block 3 you can have it here. Block 1 you can have it there. You can have more number of blocks also, but the same block you cannot have it. For example, block 1 already there, you cannot take again block 1 and keep in the same machine. That cannot be done. So you need to have different blocks. Same block cannot be stored in the same machine more than once. Clear? And your cluster size will become, depends upon the replication factor. It'll become doubled or tripled in a Hadoop. By default, the replication factor will be by default 3. You can make it to 2, or you can make it to 4. That is your choice. But by default, how many copies of the data? So block 1, block 2, it will be maintaining block 1 and block 2, right? If you make it to 3, I need to have one more block, right? So 1 copy is here, second copy is here, third copy I can also make it here, right? Anyway, so this is second, B2 is here, B2 is here, and the second copy I may be B2, I will be able to have it here, right? So you can have one machine can have many blocks, but same block you not have. B1 is there, second copy you will B1, you cannot have it there, so that cannot be done. So clear? It is what is called as a replication factor, and because of the replication factor, your data will get tripled or tripled. If you have 100 Mbps data, 100 MB data, if you 2 copies means you need to maintain the cluster size will be 200. If it is 100 terabytes of data into 3 copies means 300 terabytes of data the cluster should have. You need to increase more and more this one. Name nodes, not name nodes, the data nodes. Okay, so that is what we are going to be understanding here. The next one is what is a secondary name node. What is a name node? We know name node is master node. This is name master node is called as what? Name node. Okay, so if the name node has all the data, if this machine is not working, what will happen? Suddenly, you have a brain, the brain is not working suddenly, what will happen? So, you have to have one more backup for this machine. Clear? So, we are going to be having a one more computer. This one more computer is also available. This is what is called secondary name node. Okay, secondary name node. Why? Because if suddenly something happens to the master node, so definitely you are going to be having a lot of issues. And apart from that, it is also taking care of a lot of other things. Clear? So master node is also called name node. Name node, if goes down, you need to maintain the same data or whatever be the data, the metadata we're talking about, all the metadata is going to be there. Clear? So now that is the purpose of a name node. Name node is compulsorily you need to have. So name node, second name node, already it is implemented. So let me show what is the purpose of a name node. You have a name node and you have a secondary name node. In the name node, you have a folder called fs image and edit log. So for example, I wanted to move the file. So how can we give the commands in your cluster? So this is how we're going to be writing the command Hadoop fs file system put sales.csv into this location. This is how the Hadoop is going to be getting the data. So minus put, all of them are called Linux commands. Okay, Linux commands. If you wanted to put the data, retrieve the data, write the data, lot of commands we need to write. So the command is called Hadoop fs file system put. This file you need to put it into user Hadoop input. When you keep the data here, you're supplying the data to the cluster. From here, from this folder, the data will be loaded to here. Clear? So whenever you put the data here, and tomorrow from here, this is the command you have given, it is going to be loaded the data. But from this location, you wanted to change the data to different location. What is that you have told? So in the name node, you have given user Hadoop sales.csv file is there. But suddenly you have renamed user Hadoop new sales.csv. So what is the folder? Initially Hadoop folder, I have this file. Now Hadoop new sales.csv. Whenever you have the starting path, it will be there in the fs image in the name node. And whenever you modify the path, it is going to be storing in the edit log file. So whenever you give a new path or when you modify the path, you are going to be moving this file from here to here. So whenever you do it, what will happen? So it is going to be maintaining in two things, two places here, right? So that is what. So image is available here, edit log is also available here. But whenever you modify, the data is going to be here because of that you will have two copies. After that, what you need to do, this path you have to update it to the main. This is the main source. From there it is going to be reading all the data. But whenever you modify any path, the modified path will be here. After modification, this path has to be updated here. So this data, if you wanted to update normally, what we do with this path and this path, we're going to be checking it here. We're going to be merging. The merged data will be going here and it will get replaced here. Clear? So in the secondary name node, it is going to be also called as a backup node for, because whatever be the values that is there, the same values are going to be here. And apart from that, whenever you change any paths, all the paths are going to be will be merged here, and the merged data will go back and it will get modified. So secondary name node is also called as the backup for the name node. And whenever you modify any paths and everything, all of them will get merged here. The merged values will go back to the name net. It will get replaced here because always original data has to be maintained here. Whenever you modify, the modified value will be here. So you need to merge this. You need to merge and send it back to this. So name node is also backup of secondary name node is also backup of a name node. So if you do any this kind of a modification, that will be done here. Or anytime if the name node is not working properly, you can use secondary name node as a main name node, because whatever be the metadata that is there, the same metadata also will get maintained here. Clear? So in your application, so name node is also one more computer. Remember, this is also one more computer. This is also node. This is also node. This is also computer, right? So in this, you need to have to install Linux, Java, everything. But these are not processing your data. Data will be processed in your data node or worker node or in the slave node. Am I clear? This is the purpose of a name node. Then I'm talking about job tracker and task tracker. What is a job tracker and task tracker? In Hadoop 1.0, so when you install it, you have a name node. This is on a machine. Data node means worker node. It is one more machine. Secondary name node also one more machine. If it is goes down, whatever by the reason, we can use. And apart from that, it is also doing a lot of other activities. What is a job tracker? What is a task tracker? So job tracker is a piece of a program. It is a code, one small program. However, you have a calculator program. However, you have a Python program. So any software, it is one more small app. It is also one app. Job tracker is also small app. It will get installed. So what is a job tracker in a task tracker? So let me tell you what are these. Now, whenever you go and try to, load your data is block one data, block two data, you have sales.csv file. The data you have loaded to the cluster. So name node is going to be allocating the blocks, block number one here, block number two here, and you have a replication factor is 2, and the same block is available in data node number 3, and this is going to be available in data node number 4. So where is my block 1, where is my block 2, everything you're going to be having in the metadata. Same data is also available in this machine, right? Apart from this machine, we have one more computer. In this computer, we're going to be configuring, and as a job tracker, it is also one more machine computer. It is going to be running a job tracker. That is also part of Hadoop only, right? So whenever you submit any job, what is a job I'm talking about here? Number of rows in the sales file. So I wanted to know, this is one sales file. You may be having some 1,000 rows or 1,025 rows are available, but I wanted to count. So when you when you do any kind of a code, this is the job you are going to be submitting. This job will go to the job tracker. Remember, so job tracker is one more machine. This is the code. What is the code? Number of rows in the sales file. You wanted to count. Clear? If you wanted to count, how do you count this? So it is very, very important that you need to this activity will go to job tracker. Job tracker will talk to the name node. Hey, name node, tell me, I got one job. I wanted to find out number of rows in the sales file. I got one job. Now tell me, where did you keep data? So this will be going and asking, where is the data? Because I need to do the number of rows I would like to count in the sales file. Now tell me, where is the data? Then this guy will say, hey, your block number 1 is available here, your block number 2 is available in this. Then job tracker will establish a link to this data node number 1, data node number 2. Here you're going to be having one more small program, that is a task tracker. Clear? It is a small program. This task tracker is going to be taking the block 1 data, and it is going to be trying to do the counting number of rows. It is going to be counting, and this task tracker number 2, which is available in your data node, which is going to your data, it is going to be started doing this activity. Am I clear? So actually, job tracker will go and ask, where is the data for this job to execute. Job means a task. This one is going to be establishing a connections with the data nodes, and here task tracker small program is going to be there. This program will go and try to get the data and try to execute. Now it is going to be giving you every 2 minutes. It is telling, I have completed 30%, I have completed 32%. Now this second time it is going to be telling, I have completed 95%, I have completed 99%. Then it will say, I have completed 100%, and after few seconds it is also say, I have completed 100%. So it is going to be executing. This job is going to be monitored, because job is split into two places, the job number 1, job number 2, because job is not a single job here. Job is divided into multiple tasks. So entire job will be monitored by the job tracker, because job tracker should know whether everything is properly happening or not. So both of them have completed. It has given me the 600 rows. In this, it said, let us say 425 rows put together, right? Put together 1025 rows. So that is what you will be able to get. But if you think that it is, let me give you one more scenario. It is telling me 30% I have completed, and it is telling me 2% I have completed. Now, job tracker will be in dilemma. Why? This guy has given 30%, and the second task is not able to get it, because 30% is, and if it is giving you 25% or 28%, then I do not suspect. If I'm giving, if this fellow is telling me 30%, it is working fine. But the second guy is giving me 2%, job is completed. That means job tracker will suspect this is not working perfectly. Immediately, it will kill the job. There is a problem here. Okay. So job tracker is going to be immediately killing and going back and asking, hey, name node, tell me where is B2 data? One more copy of data of B2, because B2 machine is giving me only 2%. I wanted to kill the task. And where is this? The B2 is available in this one. It is going to be establishing a task tracker. One task tracker already will be there. It will say, hey, task tracker, you wake up and you try to take this B2 and try to do the activity. Clear? So job tracker is a machine where it is going to be spanning, the tasks to the multiple, machines, and controlling it, right? Every second, every 2 seconds, every 5 seconds, it is asking what is the percentage of completion, so that whether that machine is, working perfectly or not, the task tracker has to intimate to the job tracker. Job tracker can know it is working fine, because job tracker should not be waiting for hours together and saying that this node is not responding. Every 1 minute or 2 minutes, heartbeats are going on. Through heartbeat, it will know what is the percentage is completed, right? So like that, job tracker is going to be getting the jobs. For example, tomorrow you say, I wanted to find out sum of sales in the sales file. This is one more activity I wanted to give. So sum of sales also I wanted to implement. For example, let us give one more consideration. Replication factor is, did you understand why replication is important? Now, second one, I wanted to give sum of sales. I wanted to understand. Now, this job is already running here, and this job is running here, and the second job is also have given. So the second job, so I may not able to get it here, because same data is available here. The second job I wanted to task started here, and I wanted to start it here, because same data is available. These guys are working on the job number one, these guys are working on the job number two. If you have a one more copy of the data, same copy, right? So I can also distribute the jobs. I can span, I can allocate, I can stimulate the trackers to work on the second job. Clear? So that is also one more important factor, one more important use case. So in order to maintain, multiple copies of the, you know, co- the replication of the same data. Clear? So if anything is failing, I can switch from one task tracker to one more task tracker. If this is not working fine, I can span this, and in this data node, you will have a task tracker. Task tracker is a small program which is going to execute whatever be the job that you're going to be taking. That code will go and started executing on your data. Clear? So like that, number of jobs you're going to be giving, all the code, it can go into the task tracker, is going to be monitored by the job tracker. Clear? So we'll continue further. So what is a job tracker? What is a task tracker? I have discussed on the later classes. We'll talk about the resource manager and other node manager also. What is a name node? What is a data node? What is a secondary name node? What is a replication factor? And job tracker, task tracker, all these things we discussed clearly. Now we'll talk about remaining things on the next class, guys. If you have any questions, you will be able to ask. And this is how we're going to be supplying the data to the cluster. So in the Spark also, we'll write same, Linux commands. Okay. So if you have any questions, you're welcome.